In this video we're going to find sine, cosine and tan of any angle and plot their graph. So the first example we're going to look at is use your calculator to find the following. Sine 2 pi over 3 and B is cosine 45 and C is tan 3 pi over 4. So we'll take a look at that, and the first one is sine. Just check the first one is sine 2 pi over 3. Maybe move it across because I bring the calculator up. Sine 2 pi over 3. Now we'll take the calculator up and we'll just check R on the calculator means we are on radians, so that's good. Sine 2 pi over 3 equals. So that gives me root 3 over 2. That could be decimalized, but it's fine as we are. Second one was cosine 45 degrees. So this problem is in degrees, so we will switch our calculator so it's set in degrees. So see the R up here, we need that to show as D, and in order to do that, shift mode, select 3 for degrees, and we've got D up there. So now we're ready to go. Cosine 45 degrees is root 2 over 2. And the last example we're asked for is tan 3 pi over 4. And tan 3 pi over 4, again that's a measure of radians, so we'll switch back to degrees, shift mode, select 4. Sorry, we need to switch to radians, select 4 for radians. We now have the R for radians and we're ready to do tan 3 pi over 4. Gives us minus 1. So that's the first example complete. Let's go back and take a look at another example. Example 2. Given cosine theta is equal to 12 over 13. Without calculating theta, find sine theta and tan theta. Show each answer in the form a over b, where a and b are integers. Okay, so let's take a look at this example. We're told cosine theta equals 12 over 13. And we need to find sine theta and tan theta, showing our answer in the form of a fraction a over b. So if you consider cosine theta is in a right angle triangle, opposite over adjacent, we could look at opposite over hypotenuse, excuse me. Cosine is opposite over hypotenuse. I've said that incorrectly, totally incorrectly, apologies. So cosine theta, here's theta here, is adjacent 12 over hypotenuse 13. Now we can use Pythagoras to find what the opposite is, because we know 13 squared equals 12 squared minus whatever the opposite squared is. So opposite squared, 12 squared plus opposite squared. So opposite squared is 13 squared minus 12 squared. So bring up the calculator and opposite square root of 13 squared minus 12 squared. And the calculator tells us that equals square root of 13 squared minus 12 squared equals 5. So the opposite we now know is 5. So we don't need to calculate theta to find sine. Sine is opposite over 5, opposite over 13, while tan is opposite over adjacent, 5 over 12. So we've done that without using the without finding the value of theta. That's one way of doing it using the right angle triangle. We also have the identity that sine squared theta plus cosine squared theta always equals 1. So we could find sine from that. Sine theta equals square root of 1 minus cosine squared theta, which is 12 over 13 squared. And let's just check that on the calculator be to verify our answer. So 1 minus, let's clear that down, the square root of 1 minus 12 over 13, not 12 over 13, it should have been, yeah, it is 12 over 13, all squared, is 5 over 13. So that's exactly the same answer as we got using the triangle. Okay, so let's take a look at the last question. And the last example is sketch the curve. So the first curve we're going to sketch is sine theta between 0, for theta line between 0 and 360 degrees. The second one is this cosine theta, that's between 0 and 2 pi. And the final one is tan theta between minus 180 and 360, positive 360 degrees. So we'll take a look first of all at sine theta. Okay, so the first one we're asked to sketch is sine theta for the values of theta between 0 and 360. So that's the first full cycle of sine. So I'll draw the axis first. So the axis will go from here, say, down to here, and from here over to here. Now the easiest way to do this is to draw the wave. We know sine is periodic, so we just draw the wave between 0 and 360. Now we should know the values, the key values here. The maximum that sine will ever be will be 1. The minimum that sine will ever be will be minus 1. So those points are critical that we mark 1 and minus 1. We have sine theta on the y-axis and we have theta on the x-axis measured in degrees. So here is our 360. Here is 180. Now we should know this is 270. So if we did sine of 270, we'd get minus 1. And here is our 90 degrees. 90 and 0. So that's good enough for a sketch of the first full cycle of sine theta. If we didn't remember that, we can just simply put sine of 0 in our calculator and see that sine of 0 is 0. Or you could check a few of the points. The next sketch we need to do is cosine theta, the first full cycle, but this time we're asked to show it in radians. So 0 less than or equal to theta less than or equal to 2 pi. So again, 2 pi is the first full cycle of cosine theta. So I'm going to just skip along and draw the axis for cosine theta, starting here to here, and again here to here. Now cosine theta, we should know cosine 0 is 1. So I'm going to start the curve there, going down, 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 and up, 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 and finish there. So I need to extend that a little bit. So this is theta in terms of radians. So here is 2 pi. The period of cosine and sine are both 2 pi, but the cosine one starts at cosine 0 is 1, and here we've got pi, which is same equivalent to 180. Here we've got pi over 2, or 90 degrees. Here we've got 3 pi over 2 over 2. So the 1 and the minus 1 are most important, and we'll just make sure that that's labeled with cosine theta. Okay, so that's good enough for the first full cycle of cosine theta. The final one we're asked to sketch is tan theta. And this time, while it's in degrees, we're not just given a full cycle. We're given from minus 180 degrees between theta. Theta lies between minus 180 and 360 degrees. So I'll start this one. I'll draw the y-axis first, tan theta here. And the x-axis maybe from here over to here. So I want to mark out a couple of important points. Now we know the shape of tan should look something like this, while if we did tan of 90 degrees we would get an error. So we're going to call this one 90. That's asymptote, and then it goes up like so, where this is 180. 180, and here we'll stop at 270, and this is 360. Now because it repeats itself, we've got tan theta, and on the x-axis we have theta. It is in degrees, so I can simply continue the pattern. This will be minus 90 degrees, and there's my negative 180. So I just do that again. Okay, so there's negative 180. So there's my tan curve for values of theta between minus 180 and 360 degrees. So that's all for this video. Thank you for watching.